Okay. That's no worries.
It's the cheap and cheerful way of
Just
doing
on the cursor, yeah. No
Yeah.
problem.
Yeah, so, or, yeah, just the cursor.
Yeah, no problem. Right. Super. Thanks very much, everyone, for coming this morning and dragging yourselves out of bed on a Sunday morning. So my name's Geordie Stewart. I'm going to talk about heat pumps, but in the context of whole house retrofit. It's a short presentation. I'm just going to go through three key questions that we may sort of want answers for, and I'll have some time for Q&A at the end. Okay. So, why would you want to keep heat pump? Okay, is your home ready? And what help is there? They're the three sort of areas we want to try and cover this morning. So there's lots of reasons why you might want a heat pump, but I'm sort of focusing on sort of carbon, comfort, and cost. And I think a lot of you are here, because of your concerns about the current climate crisis. And if we look at carbon, there's a real need to stop burning things to heat our homes. Okay, so we need to move away from fossil fuels. So whatever it is, whether it's oil, coal, gas, it all involves, even biomass, it all involves burning something to heat our homes. So we need to move away from that, and we need to think about the electrification of heat. Okay, with a caveat that electricity is, the national grid is moving towards renewable sources. Okay, so why don't we just go out and buy a £15 plug-in fan from Wilco's, because that's electric, that will work, and it will. The difference is the heating efficiencies. So any electric heater is effectively 100% efficient. So that means 1 kilowatt of energy coming into your home in the form of electricity will produce 1 kilowatt of heat. Okay, and the great thing about heat pumps is, through the magic laws of physics, we can convert 1 kilowatt of energy into 3 kilowatts of heat. So there's a 300% efficiency. So direct electric, 100% efficient. Heat pumps have the ability to be around 300% efficient. If we look at other efficiencies, a gas or oil boiler, depending on its age, can be anything. If it's very old, it could be 60% efficient. If it's a modern one, it could be 90% efficient, which means you're losing 10%, even with a sort of best gas boiler. At the other end of the spectrum, a lot of people still have open fires. An open fire, anybody know the efficiencies of an open fire?
Less than 40%?
Around 10. I mean, it varies. So roughly 90% of the heat is going up the chimney and heating up the birds up there, sort of thing. So yeah. So that's the context. Comfort. Heat pumps are a different type of heat. You stand in front of a fire, you've got that sort of radiant heat in front of you, but you've got a cold back, sort of thing. So the heat pumps work by producing a sort of a lower but sort of more constant heat. So the ambient temperature can be more comfortable once you've got used to that. And I'll come on to more of that in a minute. And for example, underfloor heating complements heat pumps very well. So again, it's more of a constant ambient temperature, and we may be when we're trying to create a new home, a comfortable part of our home, we might be doing a new extension or renovating a kitchen or a bathroom or something like that, and it's an ideal time to start thinking about your overall heating strategy. Cost. So definitely moving from oil or LPG or coal to a heat pump is a sensible financial move, because the prices of all those things are increasing all the time. Moving from gas, it used to be that, as I've just explained about the efficiencies, you've got 300% efficiency, so you're using a third of the power to produce your heat, but gas used to be a third of the cost of electricity. So moving from gas to electricity, you're sort of, it's 3 up and 3 down, so you end up with parity in your costs. You know, your cost, it used to be the case that your fuel bills would be roughly the same. Now, with the current energy crisis, I can't even predict how that's going to go, because it's all gone crazy. But we all know it's only going in one direction, so I still think it's a sensible financial choice. Okay. So, is your home ready for a heat pump? Just two areas I'll cover here is to do with the fabric of your home and the sort of workability of installing a heat pump. So that 300% efficiency that I mentioned, that's if you're assuming that your home is sort of optimized in terms of its heat losses. And we always, what you really want to do is minimize your heat losses. So the most efficient heating system you can have is not to have one, because your home is so well insulated, your body heat will heat the home. That's quite an extreme passive house and not achievable for most of us, I'm sure. So, but we do want to reduce our heat losses as much as possible. Now, that means, you know, looking at your your loft, your cavity, your solid walls, your floors, your solid floors, your suspended floors, your windows, your doors, trying to reduce the heat losses by improving your fabric and improving the air tightness, importantly, because we lose a lot of heat through infiltration, through drafts taking our heat away. Okay. You could, now people have said to me, what's the point? You know, if my electricity is 100% green, renewable, why do I need to insulate my house? Because, you know, it's not causing any harm to the environment. Our national grid could not cope with us all being, you know, producing 3 times the amount of energy that we need to. So when with a transition to electricity for our heating, it's very important that we try and reduce that demand at the same time, because it would just overload our grid. Our grid is very old. It doesn't have the capacity to support us without insulating our homes at the same time. So it is very, very important.
It's also seasonal.
Well, yes, yes, yes. Yeah. So workability, you know, will it actually work in my house? And there's all sorts of things to consider. Have you got space for the outdoor unit? So the outdoor unit will vary. The one in the picture here is relatively small. It's about a 6 kilowatts. The heat pump itself will depend on the size of your property. Even well insulated, it's to do with the sort of floor area and the form of your house. So if you take my hand, you've got this surface area of you've got this many exposed areas, and each one of those is leaking heat. If your house is like that, it's the same footprint, it's the same amount of square meterage, but you've got all these external areas, and all of them are losing heat. So your house type will have an influence on your heat losses. And so you need an outdoor unit, sort of, you know, smaller than this table, somewhere to put that unit. Okay. Inside, you need a thermal store, and the best place is your airing cupboard, because it's roughly the right size for you know, putting a tank and the other gubbins that's needed in there. Now, a lot of us, when moving from traditional boilers to combi boilers, have ripped out airing cupboards. We don't have one anymore, and that's very common. And so we just have to find another space, you know, utility room or create a space. You could potentially build a little something outside, or if you can just find a corner and nook in your house somewhere to put the thermal store. It can be possible to put them in loft spaces as well if you're short on space. We need to, with the outdoor unit, just to mention, we need to do a noise assessment. You know, how is it going to annoy your neighbours? You know, and there's a set process of working out how noisy it will be for your neighbours. If we have time, I'll come on to more of that at the end. We need to look at your current piping. If you've got radiators already, if you have a wet system already, there's generally two types of piping. One is sort of the thickness of my little finger, and that's not good for heat pumps because we need a bigger pipe. That's called microbore. And the other one's roughly the size of my thumb, and that's good. Thumbs up, good. And but we would need to assess your pipework in general, just to see if it was depending on the age of the property and you know, whether it was in good condition. So your pipework can add to the cost of the installation depending on the current condition of your pipework and your stores. And then we need to look at your radiators. So heat pumps work at a lower operating temperature. So the water in your radiator from oil or gas will be about 75 degrees. It's quite sort of hot to touch sort of thing. I always used to get told off at school for putting frozen hands on them, so I told you get chill brains. But a heat pump will produce water at around 40 degrees, 45 degrees, something like that. So it's a lower operating temperature. In fact, that we want to get it as low as possible for the best efficiencies. And because of that, because it needs to transfer that heat into your room, and it's at a lower temperature, we need a larger surface area to help transfer that heat across, and that's all calculated by doing a heat loss survey, room by room. Okay.
So what you're saying is you need much bigger radiators.
So there's no yes or no. It will depend on so many factors. It depends on how you know well your house is insulated. So it's just laws of physics. We're trying to if we're trying to get your room to sort of 19 degrees and it's just transferring that heat from the radiator to that room sort of thing. So because it's at a lower temperature, you know, extreme is if your radiator was at 1,000 degrees, you need to just, you know, be emitting so much heat, it would heat up really quickly. But if it's at 1 degree, or if it's at the same temperature, it's just that transfer of heat, so basically. So it's quite often we do need to upsize the radiators, but on a new house with a new system, it may be just about okay. We can just try and see, and then if it's not, we can always come back and increase them. But that's all on an individual property. There's always a heat loss assessment, and that will tell you exactly the size of radiator you need for each room. Okay, and then you can make a choice from there. So I'll just move on to what help is available, and I'll first of all talk about the boiler upgrade scheme, which replaced the RHI, the Renewable Heat Incentive. The government now are offering a fixed grant towards the cost of installing a heat pump. That grant goes to the installer, not the householder, and it's a one-off payment upfront. So if it's an air source heat pump, that is £5,000, and if it's a ground source heat pump, that's £6,000. A typical heat pump installation may cost something between £15,000 and £25,000. It really depends on the size of the property, the complexity of the property, all the things I mentioned about the piping and the plumbing and the location of the thermal store and the outdoor unit. So there's lots of variables, but you will get £5,000 off that figure. So underflow heating is absolutely complements. It's great because you've got a large surface area to help transmit that heat. So it really complements heat pumps. Yes.
Yeah, obviously there's the cost of installation. But how do they compare, say, with
just using existing?
Well, underfloor heating will involve, if it's a suspended floor, well, in both cases, it's taking up your floor to install it. So it's an additional, quite a additional expense, and we need to make sure it's insulated at the same time.
Is it better?
It's, yeah, I mean, you just want a large surface area to transmit that heat. So it's always preferable, if you can, do underfloor heating, yes.
Final question. Would it be okay to put it on the ground floor of a two-storey house, and would the heat going up be sufficient to warm the?
So it will be modelled. We often do ground floor, underfloor insulation, underfloor heating, and radiators in the bedrooms upstairs. But we've recently done 5 stories of underfloor heating on every floor, sort of thing. So but you will still need heat emitters of some sort upstairs. Yes. But case by case, that's all modelled. The final sort of part of this is sort of how, what help is available. So just a little bit about sort of Cosy Homes, which is a home retrofitting service that I manage. And so basically we can help you through that journey towards a heat pump by carrying out a home assessment and producing what we call a whole house plan. This is like a midterm plan, and with sort of helping you with your path to sort of net zero, and we'll model your house as it is currently, and we will model it with also all the potential retrofit measures that we can do to reduce those heat losses that I've been talking about. So how we can help you, with all those things, with your fabric to reduce your heat losses. And then once we've achieved that, we can then size up the appropriate size heat pump, because if you do it the other way around, you will end up with a heat pump that's too big for your property, and it won't be as efficient because you're running something less efficiently. So we can sort of help you on that journey, right from the initial assessment, what's right for your property, what needs to be done to make you heat pump ready. And importantly, we work, we're all qualified retrofit coordinators, and we work with local contractors, both in installing the retrofit measures, the fabric measures, but also we work with local heating engineers to help you on that journey, carry out the heat loss survey, help you on that journey to install your heat pump as well. Okay, so Cosy Homes is only Oxfordshire, but there are other schemes that our partners work with in London, Sussex, Manchester currently. Yeah. Okay. Right, so that's I'll take some questions. If you wanted to know anything more about noise, I can answer a few questions on noise. I had a couple of slides on that as well, but I'll top now. Sorry. Yeah.
So do you do air-to-air heat pumps?
Air-to-air, so our heating engineers do install air-to-air as well. So the only where that may be the best option is where you currently don't have radiator, a wet system. So if you've currently got storage heaters, you've got no wet radiators at all, it can be quite cost prohibitive to completely put in a new piping system. So air-to-air may be an option there. Yeah.
You've got micro, which I think are sort of plastic. I mean, is that very expensive to replace?
It's literally the cost of, so we are currently near Cumnor, it's a 1980s house, it's all microbore, and we're literally removing the entire plumbing system and putting in the 50mm pipe. So we're also working on another property where one of our installers has got a way of overcoming that, and they are working with the microbore, but they've got a magic way of making it work. So I'm not quite sure what that is, but generally, and it has, it's all been properly assessed and it's been successful. But I think generally microbore needs to come out and that needs to go in.
Like starting from scratch,
Yeah.
So if I can just say there's 3 more minutes, and then I'm going to have to figure you all out. But Geordie is here all day.
Yeah.
So more questions.
Yeah.
Yeah, I'd like to know about the noise.
Yes, sir. Okay, so I conveniently have another slide on noise. So This is a slide from Mitsubishi. We're not aligned to any company, but they currently say they offer the quietest model on the market. So here you have, so it's all measured in decibels. So a siren is 120 decibels, a hoover is about 80 decibels, a talking me now is about 60 decibels, and a library is about 40 decibels. So their heat pump is, if you put a microphone on the fan, will be 58 decibels, and if you step 1 meter away, it will be 45 decibels. So on a par with a library, sort of less than talking and a par with the library. And with the noise assessment, it's all about, it's sort of line of sight to your neighbour's habitable room or bedroom, and take step 1 meter back from that. And it's, there's MCS, the micro generation certification body, have a set procedure for monitoring that. To put it in context, I was showing some clients a heat pump that would installed in North Oxford, and we're standing in the back garden next to the heat pump, and it was a big unit, and they asked me to switch it on, and it already was on, it was running, they didn't realise. Conveniently, the neighbour's gas boiler just came on, and it was like a rocket, sort of the flue, you know, was next to it. So it was, you know, but nobody talks about boiler flues, it's a thing. So there is a conception, preconception, you know, that oh, it's too noisy, I don't want that, I couldn't live with that. But from my experience, and noise is a funny thing, it's not a, it's all how, you know, there's tones and pitches and things like that. But my experience has been very positive.
No, you wouldn't upset the dog and stuff.
Yeah. Sorry.
Can you be installed with brackets above rather than on the ground?
They can, yes. The only thing is if it's high up, it adds to the, it means for your annual maintenance, people have to work at heights, and that will just add to the cost of your maintenance, because there's all sorts of health and safety about working at heights. But yes, they can be mounted on brackets. If you think of air conditioning in you know, Delhi or something like that, I mean, you'll see whole box covered in it's effectively the same type of unit, but it's just working the other way around. So I think so. Yes, they can. Yeah. Okay. Sorry, one more, just last one. Sorry.
Perhaps a little tricky in small Oxford terrace houses.
Well, funnily enough, that's in Cowley on a terrace house. So that is at the back. Yes, yeah. That was just another thing about the noise. But yes, I mean, it is obviously when you've got those long, narrow, thin gardens. The other thing is you're supposed to be 1 meter from your neighbour's boundary, but with consent with your neighbour, you can be closer. But it needs that consent. So it is more tricky on those narrow terraces, but we've done plenty with no problem. Yeah. So flats, we would have to. I wouldn't say, I don't think anything's with the right will is impossible. I think it's more complex because you either have to have it at the ground and a longer pipe getting up to your property, or mount it on the wall of the flat, sort of thing. So it would have to be just assessed whether that was the case.
Thank you, Geordie. Thank you very much, everyone. Geordie is outside, so do carry on, go and ask him what's not questions. Please do fill in all your cards and then leave them on your seats as you leave. Thank you very much for coming.
Thank you. Thank you. Thanks. Got my sticker.